Alright, so ethylamine, which is also known as ethanamine, has some important fields related to chemistry. Now, to start off with, specifically with T roots, it has a chemical reaction involved between three substances, where ethylamine serves as a precursor. So the way this chemical reaction works is L-alanine is converted to L-gumite, which is then produced as an L-theanine. But in the step between L-glutamate and L-theanine, ethylamine takes place within that step to serve as a precursor, which allows this chemical reaction to occur, which also contributes on how this T is able on the T's ability to do its function and its taste. Now, ethylamine can also be stabilizes rubber latex to produce rubber gloves. In addition, the substance within this substance in the form of liquid can be used as a solvent to refine petroleum and vegetable oils. Now, application or usage of ethylamine includes the following on how this substance is popular with agrochemical field, or also known as the agricultural field, mostly due to the concept of economics and how farmers wish to improve efficiency and production to keep up with the demand of consumers. Now, a specific example is that ethylamine is a precursor, such as how it's a precursor for T roots through atrazine, zemazyne, and xynozyme to produce weed killers. Now, ethylamine can also behave as a catalyst to speed up the rate of production of polyurethane foam and in dyes as well. Now, here's the 2D structure of ethylamine again, but more specifically, I will utilize this to identify the molecular properties. Now, starting off with the functional group, as we can see, the central atom that's furthest to the right is nitrogen, and it's bonded to two hydrogens. Therefore, it is considered an amine group. Now, before I count, I determine the number of sigma and pi bonds. Single bond means 1 sigma bond, 0 pi bonds. Double bond, 1 sigma bond, and 1 pi bond. A triple bond means 1 sigma bond and 2 pi bonds. Now, with this in mind, carbon 1 and carbon 2, they both have 4 electron domains, and they're all single bonds. Therefore, we have 4 sigma bonds, but 0 pi bonds. Now, nitrogen, on the other hand, although it has three single bonds, it still has 4 electron domains due to the fact that it also has a lone pair. Now with that being nitrogen only having 3 single bonds, it has only sigma bonds then, and no pi bonds. Now, only having sigma bonds tells us that the hybridization of all 3 central atoms is sp3. And now to determine the shape of said central atom, for carbon 1 and carbon 2, it'll be tetrahedral due to both of them having 4 electron domains. And then nitrogen, although it has 4 electron domains, it has that lone pair, so it has a shape of a trigonal pyramidal. Now, although the carbon and nitrogen have slightly different shapes, they both share the same bond angle of 109.5. And then when it comes to polarity, the molecule can either be partially nonpolar, partially polar, overall polar, or overall nonpolar. So with that in mind, we'll consider the polarity of each individual central atom. Now, to start off with carbon 1 and carbon 2, they're both considered polar. Now, considering the polarity of nitrogen, on the other hand, it's also considered as being polar. Now, since all 3 central atoms are polar, then ethylamine as a whole can be considered as a molecule that's overall very polar. And now here's my slide with the references and citation. Thank you.